example, sooner that in compare with the NHRP resolution request. Because of that, the R3 should answer to the router 4. To the router 1 means the NHS. Look at here, quad 2 to quad. Here we have the answer from the quad 3, okay, to the quad 2 reverse direction, and after that this is ICMP echo reply. Let me to write here ICMP echo reply, and then the GRE from router 3 to the router 1. Okay, because until now the router 3 doesn't receive the NHRP resolution request. Okay, and this ICMP echo reply received by the router 1, let me to show you in the R4, received by the router 1, and then again the router 1 now should encapsulate it to the router 2. This is R1. Okay, ICMP echo reply from quad 3 to quad 2. Source is 10.1.4.1, destination is 10.2.4.2. Okay, actually the router 2 received its reply for the first ICMP echo request, and in this time now the router 3 answered with the for example NHRP resolution reply to the router 2. Now router 2 has the NVMe address of the router 3. Because of that, in the next ICMP echo it can use it. Look at here, in the next ICMP echo, this is the step for example 7, this is the step 8, and then this is the step 9. In the step 9, the next ICMP echo can encapsulate it directly into the router 3. Look at here, in the router 2, now in the NHRP map cache, NHRP cache, we have this information. First, the tunnel address is 192.168.123.3, and then NVMe address is the for example 10.3.4.3. that's it. Because of that, it can send directly its ICMP echo, its other ICMP echo to the router 3 directly. Look at here, this is the R1 ICMP echo request. This is ICMP echo request. The next ICMP request from quad 2 to quad 3. Again, this is GRE, and then here we have 10.2.4.2. Destination is 10.3.4.3. Okay, and also the router 3 can answer this packet. Look at here, ICMP echo reply, and then here we have again the source is quad 3, destination is quad 2, and also GRE header, and after that from the 10.3.4.3 to the 10.2.4.2. So easy. Because of that, when we are using the traceroute command, the first packet is forwarding from the router 1, okay, to the router 3, but other packets are forwarding directly between the router 2 and the router 3. This is easy, only you should review all of the process. All right, until now we have learned about the DMVPN phase 2, what is happening and how we can configure it. Also about the routing, we have used the static routing. Now let me to talk about the configuration of the DMVPN phase 2, okay, with dynamic routing. For example, we can start with the RIP. Here again we have some detail. Let me to show you these details. All of this information is important for us, and it can help us about the process. Because of that, let me to talk about the RIP configuration. And also first we should remove the static routes. Let me to remove them. In the router 1 we have two static routes. Okay, you can see the two static routes here. This is the first static routes and this is the second static route. Now we don't have any static route in the router 1. About the overlay, show IP route can show us here these two static routes are for underlay. Here we don't have any static route for quad 2 and quad 3. Also in the router 2, show a run, okay, then include IP route. I want to remove all of the static routes, and then conft. No, we should remove the static routes of the overlay, not underlay. After that, this static route. Now here we don't have again any static route. Also in the router 3, let me to configure, let me to use the no, again the first static route and also the second static route. Now the first routing protocol that I'm going to use it is the RIP. What is happening in the RIP? Look at here, we should configure it, and you have learned about the RIP in the previous scenario. you know that in RIP, when we are using RIP in the, for example, DMVPN phase 1, we have disabled the split horizon rule, okay? But here, let me to explain it. Look at here, we can configure in the router 1 these commands for RIP only. Router RIP, then version 2, after that, no auto summary, and then network, okay, network 1.0.0.0, and after that here we can configure the for example network 192.168.123.0. That's it. This is the configuration of R1 about the RIP, also R2 about the RIP, and also R3. Only in the R2 we should configure network 1.0.0.0. We should remove it and use the network 2.0.0.0, and also network 192.168.123.0. Again, in the router 3, network is a 3.0, and also network 192.168.123.0. Here, don't forget, we should enable learning from the source from the multicast. We can use this command, and I have explained it before. IP NHRP. You know that here we are using IP NHRP map multicast dynamic. Map multicast dynamic in the hub router. Also here, you know that now we don't have point-to-point GRE tunnel on the router 2 and router 3. And also we want to send the NHRP, or we want to send the RIP update or the routing protocol update, okay, with multicast packet. You need to enable it. Okay, how we can enable sending the multicast? It is so easy. Look at here in the spoke router, okay, or spoke routers, we should configure IP NHRP, okay, map multicast. But here we don't use map multicast dynamic because we want to send or encapsulate our multicast packets to the router 1, okay, to the NHS. Because of that, we are configuring IP NHRP map multicast. Then we are configuring the IP address of the NHS 192. Here we should configure the physical address of the NHS, because this is the IP address that we are encapsulating the multicast packet to this destination, means 10141. Okay, look at here. You know that we know about the NHS. NHS IP address is in the overlay is 192.168.123.1. Okay, and we can encapsulate the packets to this NHS. But now the problem is that we want to encapsulate RIP update, multicast RIP update to the router 1, okay, because of the only to router 1, not other routers. Because of that, we should use IP NHRP map multicast to 10.141. Means when you want to advertise the multicast update, you need to encapsulate it in the outer header with the destination IP of 10.141. So easy. Okay, after that, here we should configure again IP NHRP map, then multicast, again 10.141. That's it. You know that here we don't have point-to-point tunnel. Because of that, R2 and R3 don't know about the destination IP address in the outgoing header, in the outer header. We need to configure it. It is so easy to understand that we should configure the destination IP in the destination physical address, actually, in the interface tunnel configuration. If you don't configure it, about the multicast update of the RIP or EIGRP or OSPF, we don't have destination physical address. You know that in previous video we didn't configure this command. Why? Because in previous video we had one point-to-point tunnel, and in the point-to-point tunnel the destination IP is for example obvious, and we can use it. All right, let me to use this configuration inside the for example router 1. Look at here, in interface tunnel 0 IP NHRP map, okay, multicast dynamic. Here we are using map dynamic. Why? Because we should learn about all of the physical address that we are receiving from them RIP update, okay, and because maybe we have for example 100 NHC and we don't want to configure each of them. But in the router 2 and router 3 we have only one peer, and that is the router 1. Because of that we should configure it. We don't want to learn other multicast, other destination addresses received from the multicast update, okay. IP NHRP map, multicast dynamic. That's it. Here we don't have any new commands. Also, we should configure RIP, router RIP, version 2, and then version 2. Okay,